Okay, so I'm going to do a few examples from section 1.9, absolute value. So first, if I have an absolute value equation, then there are numbers that I can plug into this that makes it true. And with absolute values, there's actually usually two numbers that you can plug in. So what numbers can I plug in to make this true? Well, if I plug in x equals 1, for example, let's do it and see what happens. We get 1 plus 2. That's the absolute value of 3, and the absolute value of 3 is 3, so that is true. That's correct. If I plug in x is -1, I will get -1 plus 2, which is the absolute value of 1, which is 1, and that's not equal to 3, so that would not be correct. But there is another number that this works and would be correct, and that is if we plug in a number that makes the inside of this bracket equal to -3. So what number makes the inside of that equal to -3? Well, let's try -5. If I put -5 in, -5 plus 2 is -3, and the absolute value of -3 is 3. Any number in the absolute value bracket is a distance, and distance is always positive. So if it's a negative or a positive in the bracket, that's positive. Okay, let's change this a little bit. Let's say we have, so this is example 1, and let's say example 2 says the absolute value of x plus 3 is equal to 4. So there are two answers that work here. And suppose I didn't give you, or I didn't ask you for the answers, but I gave you a list to check. So check if these are the answers. So check x equals 1, x equals 3, x equals -7, x equals -4. So by plugging each of these in, we can see which one works. So 1 plus 3, the absolute value of 1 plus 3 is 4. The absolute value of 4 is 4, so this one works. If I plug in 3, 3 plus 3, well, that's 6. The absolute value of 6 is 6, so that is not true. If I plug in -7, I get -4, and the absolute value of -4 is 4, so that one works, and the last one won't work. -4 plus 3, the absolute value of -1 is 1. But if I change that to an inequality sign, then we have more chance of these things working. So for example, if I did that same question, but let's change that to be the absolute value of x plus 2 is greater than or equal to 4. So if I were checking these same numbers, which ones work now? Well, when I plug in x equals 1, I get 1 plus 3, which is 4, and I would say greater than or equal to 4, so that one works. If I plug in 3, I get x plus 2. Oh, I didn't put the exact same question, sorry. Let's just fix that. This was supposed to be a 3. Okay, so this is right, but this is 3 plus 3, which is the absolute value of 6, which is 6, and yes, 6 is greater than 4, so this is now an answer. When I plug in -7, it will also work. -7 plus 3 is equal to -4, and the absolute value of -4 is 4. And then -4 won't work. And let's add another, what if I said -10? Okay, so let's plug in -4. That gives me the absolute value of -1, which is 1. That is not bigger than 4, so this one does not work. And the last one, 10, so -10 plus 3 is absolute value of -7, and -7 is 7. 7 is bigger than 4, so this one works. So plugging them in, but remember to take the absolute value to see which ones work. Now, the other thing about absolute values that make people a little bit confused is when we have an absolute value and an inequality. The best way to do this is to find the numbers that work and make it equal, like this equal 4, and then worry about it if it's an inequality later. So like this question up here, I had an equal sign, and there was 2 answers that work when it's equal. But then when it's an inequality sign, there could be more than 2 that work. There are 2 that make it equal 4, but then there are lots of others that I could plug in that would make it greater than 4, and then lots of others that I could plug in that would make it not work. So looking at an inequality equation, we can either have a quadratic or not. If I said x minus 2 is equal to 3, then there are 2 cases that will work. Case 1 is when the inside of that bracket is equal to 3. So 5 would be an answer that if I plug it in here, I would get 3, and I would actually get positive 3. You see, I tried the positive 3. So 5 minus 2 is 3, and that's positive 3. That works. Case 2 is if the inside of that bracket is equal to negative 3. That gives me negative 1. So what that's saying is if I plug negative 1 in, I get absolute value of negative 3, which is positive 3, and that also works. So making it equal to either the plus or the minus will give you the numbers that work and make it equal to 3. And then if the question had said greater than or equal to or less than or equal to or just less than or just greater than, say we wanted less than 3 instead of equal 3, we would still find these 2 numbers, and they are negative 1 and 5. But the negative 1 and the 5 don't work now because I didn't put an equal sign. And then where would work here? So these are what makes it equal to 3. But we don't want where it equals 3. We want where it's less than 3. So we can try. There are 3 possible intervals here that if we plug in a number on this side, like negative 2, I get negative 4, which is 4. Well, that's bigger than 3, and we wanted less than 3, so that doesn't work. If I try a number in between in this interval, let's say 0, 0 minus 2 is negative 2, which is 2, and 2 is less than 3. Yes, that works. And then over here, if I try like a number bigger, say 10, in this interval, so 10 minus 2 in the absolute value brackets is 8, and 8 is bigger than 3, so this one does not work. So now it's one place that works, so our answer has to be one equation, and we say it is all the x values that are between these but not equal, because equal makes it a 3 exactly, and we don't want a 3. We want only the ones less than 3. So these ones made it equal to 3, so we don't want those, and we don't want anything that makes it greater than 3, which is those 2 sides. And then if we had to draw a number line, we would say it's in between these. We put a big empty circle, shade on the number line, not above or below, and that this would be the full solution. Okay, so let's do one more with a quadratic. So say we have x squared minus 1 is less than or equal to 5. So what we do first is we see where this equals 5, and then we can put those numbers on a number line and test it. So x squared minus 1 is equal to either 5, that would be case 1, the positive inside, or case 2, we would say x squared minus 1 is equal to negative 5, the inside, because it's an absolute value. We have those 2 situations that would give us x values that are equal to 5. And then we're going to see where on the number line it's greater than or less than. So these are quadratics. So with quadratics, we move everything to one side. So x squared minus 6 equals 0, and factor that. It's a difference of squares. So we'd say x equals root 6, or x is equal to minus root 6. The other thing you could do is say x squared equals 6 plus or minus the square root of 6, but people often forget the plus or minus if they do it that way. So here's two numbers. They're not nice numbers, but that's what happens in the real world. They don't always end up as nice numbers. So over here, if we bring the 5 over, it's be positive. So x squared plus 4 equals 0, and this is none. That x squared equals -4. If you take the square root, we can't have the square root of a negative, so there's no answers here. So for this situation, but we could have ended up with numbers in both case 1 and case 2 that work, but we didn't. We just had numbers in case 1 that works. So if we put those on a number line, smaller number first, and then just test each of these regions. So say we test this first region, square root of 6. Well, square root of 4 is 2. And square root of 9 is 3. So 6 is in between 2 and 3. So if I wanted less than that, I could say -3. I could even go like really far and say -10. Maybe in between those are a plus and a minus. So a 0 is always in between, and maybe bigger than square root of 6, like square root of 9 is bigger. So 3, or we could go really big and go 10. 10s are easy to plug in anyway. And where do we plug these in? We're trying to find out. We know these are where that's equal to 5, but we want to know where it's less than 5. So we're looking at these intervals to see where it's less than 5. So if I plug -10 in, -10 squared minus 1, that's in absolute value brackets. That's 100 minus 1 is equal to 99. 99 is clearly not smaller than 5, so that won't work. Plugging in the 0, I think, will be the only one that works. This gives me -1, which is 1, and 1 is less than 5, so this one works. And the 10 squared is going to give me the same as the first one, because 10 squared or -10 squared is both 100. So this is 99. So these ones don't work. And again, this is in between. So we would say that our answer is -√6, between -√6 and +√6, and this time there was an equal sign. We do want the ones that equal 5 exactly, and if we were to draw it on a number line, you don't need to put more numbers than the ones that we want, but this time we would color them in. Okay, so that's a little bit of a crash course. Just backing up a minute, what we want to do is whenever there's an equal or an absolute value, do case 1 and case 2 where it's equal. And if there's an inequality, test them on a number line. And if there's no inequality, then you just have the numbers when you do case 1 and case 2. That would be your answer. Okay, that should be a little bit of help. Let me know if you're still having troubles. Bye for now.